PLEXOS Basic Modeling, Part 2. Scenario-based analysis. In this course, we will learn how to set up and effectively utilize scenarios. The motivation behind scenario analysis is to analyze the effects of changing values for certain properties without reconstructing the whole system. Some examples of this would be comparing high versus low fuel prices, analyzing the impact of wet versus dry hydro years, or seeing how different generator characteristics affect the results. So let's continue with this last example to better understand scenario analysis in PLEXOS. Understanding scenarios. In this simple system, we have two generators, Gen 1 and Gen 2. Each generator has certain properties defined. For example, we define values for the max capacity, ramp rate, and heat rate. This is considered our base data. If we would like to test how changing the value of ramp rate or heat rate impacts the optimization, we could do this by creating a scenario and tagging these new values with the scenario. But what data will be used at runtime? We see in this diagram that when scenario A is included in the simulation run, that the blue values will override the base data. This is the main idea behind scenarios. The values for the base setup and scenario A are stored in the input database, and the user can determine which values to use at runtime. What is a scenario in PLEXOS? Scenarios are a class in PLEXOS, so the user can create a scenario object in the same way as other objects are created. Scenarios define a set of values that can be labeled with a particular scenario name. We can see that the scenarios class falls under the data category in the objects tree. In this case, the scenario is named Run of River. Next, we'll go over how to create a scenario. Setting up scenarios in PLEXOS. First, define a scenario object in the scenarios class by right-clicking on scenarios in the object tree. Select New Scenario from the drop-down and name the scenario. Once the scenario object is created, tag the properties with the scenario. Use the drop-down list in the field scenario to tag a particular value of a property with the desired scenario. This is done in the Properties tab of the Data Grid pane. You can also view all the properties tagged with a scenario. To do this, highlight the scenario in the scenario class of the objects tree. All properties under scenario will be displayed in the Properties tab of the Data Grid pane, as shown here. The final step to including these scenario tagged values in the optimization is to include the scenario in a simulation run. To do this, the user has to establish a membership between the scenario and the model of choice. There are 3 ways to establish this membership, and we will go over them in more detail over the next few slides. The first method to establishing the membership between a scenario and model is to open the model's properties and add the scenario. To do this, highlight the model in the objects tree, then right-click on the model and a drop-down will appear. Select Properties. In Properties, double-click on any scenario on the left pane. Then you will be able to add the scenario to establish the membership. The second method to establishing the membership between the model and the scenario is through the membership tree. Once you have highlighted the model of choice in the objects tree, in this case, we have highlighted base plus run of river, we can go to the corresponding membership tree. From here, we can double-click scenarios. All the possible scenarios will appear on the left side. When we add a scenario, it gets moved over to the right side, as we've shown in this case. The final way to include a scenario in a simulation run is simply to drag and drop the scenario object onto the model object. To do this, first select the scenario and hold down the left mouse key. Then drag the cursor up to the model, which you want to add the scenario to. Ensure that the model name turns blue, and then release the left mouse key. This should add your scenario to your model. Excluding a scenario from a simulation. To exclude a scenario from a simulation, remove the membership between the scenario and model. One way to do this is on the same page where we added the scenario. We also have the option to remove the scenario from the model.scenarios membership. The model scenario grid. To have an overview of which scenarios are being used in which models, we have the model scenario grid. To view this, right-click on Scenarios and in the drop-down select Model Scenario Grid. In this grid, the user can select or deselect which scenarios are used in which models. In this case, the run-of-river scenario is only used in the model base plus run-of-river. So this is an additional way to add or remove a scenario from a simulation run. You could also view the model scenario grid by right-clicking on the model's category. Scenario priority. When a property is tagged with more than one scenario, these scenarios may need to be prioritized. By default, the properties tagged by scenarios are read in alphabetical order based on their scenario names. The final properties that are read in will be effective in the simulation. So let's consider this further with an example. We return to our initial setup of 2 generators with 3 properties defined. We then created scenario A with different values for one of the ramp rates and one of the heat rates. But we also have another scenario we are considering, and this is scenario B, which has different values for max capacity for Gen 1 and a slightly different heat rate for Gen 2. Now, if we include both scenario A and scenario B in our simulation run, which values will be used? Well, by default, the scenarios will be read in alphabetically. So scenario A will read first, then scenario B. Because the last values read in will be effective, we see that the data used in the simulation is shown here. Note that Gen 2's heat rate had 3 values defined for it, one for base, one for scenario A, and one for scenario B. The value for scenario B is used in the simulation as it was the last value read in. This is because the default prioritization is based on the alphabetical order read in of the scenario names. So the question is, how can we set the priority of the scenarios instead of using this default? We can do this by setting the scenario read order property. This property will allow us to override the default priorities. Scenarios with higher read order will have higher priority. In other words, the scenario with higher read order will overwrite the same properties that read in previously. So for example, if we consider scenario A and scenario B again, we could reprioritize them. In this case, for scenario A, we set the read order to 2. For scenario B, we set the read order to 1. Scenario B has the lower read order, so is read in first. Then scenario A is read in. So if any properties are tagged with both scenarios, values from scenario A will be used. We've considered until this point changing properties like max capacity, heat rate, and ramp rate for existing generators. But what if we want to toggle a generator in and out of an optimization? To do this, we can put a scenario on the key property. Each class has a key property that toggles an object in or out of the optimization. This is shown in red in the property tree. For the generator class, the key property is units, the default value of which is 0. By setting the units to a value greater than 0, we include the generator in the simulation run. So we can use scenarios to compare 2 runs, one with and one without this generator, by tagging the scenario to the units property. This is what we'll do in the next exercise.